So you'll have to forgive the printer printing for the noise, but go ahead and give you a tour of what I got here. I got some safety duct tape, just in case if something goes wrong. It also helps for mounting it, because instead of just, hovering in midair, let's see if I can, there we go. Instead of just hovering in midair, it's nice to have it actually be on something while you mount everything. But I have a wooden beam that goes all the way behind that I can compress up against and hold this nice and firm against the bed. I have a little doohickey in yonder that is screwed into this that allows that most of my vertical force is. These are here just to apply the moment, both X and Y, depending on how you want to look at it. This is my beam that I use to apply the moment to the bed, this moment to the bed. These apply this moment to the bed. I have some really nice planetary gears in Chandler. Yes, nice planetary gears. They got the nice double herringbone, quadruple helical gears in here. Got a nice large moment arm there. That's about probably 2 feet, 0.7 meters ish. Just about. Yeah, planetary gears that act as bearings, and also both thrust and axial bearings. I guess it would be radial force bearings. Got my horizontal member that goes to the first powered axis motor. It's just a small, I actually don't even know the power of it. It's kind of sketchy exactly how I got it. But one of the motors, one of the motor configurations kind of has a torque limit of 15 kilogram centimeters, which is like 1.5 Newton meters. But I don't know the gearing ratio of that one. This one is 2 RPM, and it does what it needs to. It gets there eventually. I have room in there. Let's see if I can move this out a bit. I do have room in there for a second one. I could mount it right there. Just like how that one's right there. I can mount this one on the other side, and I can double the torque. I actually have room to up to hextuple the torque if I need to. That's a gigantic planetary gear. This is all a module of 2 millimeters. That's what I could get the best accuracy, speed and accuracy. That's what I get with my speed and accuracy that I was wanting to get them out with. There's a lot of so there's the ring gear that the main arm connects to. Then there's the planet carrier, which you don't understand on this. Get me a lot closer. Sorry about that. So we have the ring gear, and then we have the planet carrier here. So ring gear, planet carrier. The planet carrier goes onto the planets of the planetary gear set and holds this arm. This motor spins the planet, which has a 7-to-1 gear reduction from the planet to the ring. So this thing has, several hundred, I don't know, probably a couple hundred, maybe a couple thousand gear reduction in just this metal bit. And then I have another 7 gear reduction in the planetary gear that goes to this member, to the second, what's it called? Powered axis. That's similar to an elbow. This is similar to a wrist. And then this would be similar to a shoulder. Let me get up a bit higher. No, that's worse. Let me get back down a bit. Yeah, this is similar to a wrist. Also has a planetary gear. I don't remember the ratio. I just remember that I was trying to fit something. I have notes on it somewhere. I don't really care. It serves its purpose. Same motor. And this one moves a little bit faster, but over a shorter arm, so it's about the same speed, linear speed. Again, it's all of these are the same gear thickness, so I could just print the same gear over and over again. These gears, I could just print them over and over again, and they're just like probably 30 degree. I have it all saved somewhere, but I think it's 30 degree helix angle quadruple helical gears or double herringbone, depending on how you look at it. And what's nice about a herringbone is that it allows you to have that to resist that thrust forces. So I can have this member, be at a 45-degree angle and not have it slip off. If this was a spur gear, or if this was maybe if it was a bevel, this thing would actually just slip off of the sun or planet gears, and that would be an issue. I have some double pole, double throw switches that I use to control the direction of the motors. Someday later, I might might hook up with some brains up to this thing, like an Arduino or some sort of AT-Tiny or something, just to control it. To have more smooth movements, maybe I could do like some sort of linearity or rectilinearity control, allowing it to move straight up or straight down. This piece actually cracked, so I've just covered it in hot glue just to give it a little bit more strength. I've already printed off the next piece. I just need to mount it on now. Yeah, just don't make sure you know what you're doing when you're mounting these. And I just got too lazy and rushed it. Oh yeah, something I forgot to mention. This piece here, there's also a little bit of hot glue here, just in case. Helps me sleep better at night. And some of these screws are longer just because I didn't feel like cutting them, and so I just left them in. I really wanted to see the project get done eventually. But so this piece here, my printer's only 10 inches big, so I can't print all of these some of these all in one go. Or if I could, there'd be risk of warping, damaging the entire part. So if I cut up into smaller parts, I have less catastrophic error if something was wrong. I don't have to scrap the whole part, or if I do have to scrap the whole part, it's only a small section of it that has to be scrapped. So I have a back plate, a front plate, depending on how you want to look at it. Then I have the tendon that attaches the joint to the bone, I guess you could call it, the in between, the ligament, whatever you want to call it. I call it a tendon. And this is also a separate piece. So what came in handy is that I wanted to reprint this piece because I had to redesign it. And instead of having to redesign this entire thing that I would have done in previous iterations, I could just reprint this one piece, unscrew here, and here, and just pop it in. And then from here on down has all been recycled from my last project. This axis of rotation always points down, just because of like gravity is how it will. Like I can move it out if I wanted to, but like gravity will just move it back. And of course, these screws are too long because I'm too lazy to cut them to size or use all thread or whatever. Who cares? It serves its purpose. Then, of course, I have the recycled 3 degrees of freedom. So I got one. I got, let's see if I can do this one hand. 2, and then 3, and then yeah. Yeah, that piece of duct tape isn't really being used. It's not taught. These motors are like really low power. That's like a 0.5 amp fuse at 12 volts. So there's really almost no energy, like very low energy going through these things. I think in order to lift this, I need like a watt or so, or 1 or 2 watts. And then you can account for like inefficiencies and stuff. Maybe I need like 3 watts or whatever. But these are some pretty weak motors, which I'd rather have because they're cheaper and a few other reasons. Let's see what other interesting things about this that I have noticed, or that I would like to talk about. In some of my other designs, I had issues with rigidity, with the torsional resistance. So these two would want to slip past each other, and would do that number. And then, which the beauty of a structure like this is that there's a lot of strength in this direction. It really wants to resist that, but it's very weak in this direction. It doesn't want to resist. It doesn't really want to resist this. And if it were to bend like this, it would be then the direction in which it's weak would be in line with gravity. And it would break a lot easier. So I have these in here, piece of metal, just holding these nice and rigidly, and I'm actually quite pleased with how this acts because each of these are independent of each other. I got some dog bones just to keep the distance in here between these two lines, keep them nice and parallel-ish. Yeah, I think that's most of it. All right, so this is just a quick little tour, nice and some close-ups, some interesting stuff. stuff that I find interesting, noteworthy. And then, super glue just in case. Helps me sleep better at night because not everything's fully done to where it needs to be. But yeah, this is technically it's a 7 degree of freedom because I got one here, got one at the shoulder. I got two at the elbow, or the second at the elbow, third at the wrist. Technically, I guess this would be a finger, the fourth at the finger. And then I have 3 all inside here. I have pitch, yaw, and then roll. So that totals to 7. But this one always points down, so it's like, 6.5. Yeah, so that's the tour of the 7 degree, 80 inch. This thing goes out 80 inches from here to, if this were completely extended out, so I used to have it because that's where my head used to be. This would have 80 inches of range. 80 inch, 7 degree, 6 degree of freedom. Monitor arm. Yeah, I'm quite pleased.